notes there for lesson 1. So let's go to page 2, the definitions for static. So I think we can mark the first 3 here. Conductors, insulators, semiconductors. Conductors are materials with a very low resistivity. Now we haven't come across resistivity up to now, but we'll see what that means as we go. Okay, so underline resistivity. Okay, so conductors are materials with very low resistivity, insulators are materials with very high resistivity, semiconductors are materials with a resistivity between that of an insulator and conductor. We'll come back to resistivity, but effectively you can't say that what's the resistance of copper, because you'll have to say, well, what length of copper, what shape is the copper, and so on. But you can say the resistivity of copper, because it's the resistance of unit volume. In the same way as you can say the mass of copper, but you can say the density of copper, which is the mass per unit volume. So you've mass and you've density, which is a more precise, and you've resistance and resistivity. We will return to that when we're doing current electricity, but I think at the moment we've conductors, we've insulators. Conductors, low resistivity; insulators, high resistivity; semiconductors in between. Semiconductors sound a bit bizarre. They're the electronics, the silicon, and so on, which we will again come back to later, but I think the definitions are clear enough. Coulomb's law, okay, so it's in the tables, and at this stage hopefully we have an idea of what's going on there. Okay, so we're going to mark that as well. Okay, so move forward to page 3 and just mark Coulomb's law. We're happy with that. Okay, and we're happy with the first part here. Okay, direction of force, like charges repel and like charges attract. Okay, and finally on page 4, okay, a little bit of work here, electrification by contact. Okay, so I think that should be clear from what we do, so have a read through that and mark it as done, and demo direction of force between charges. Okay, so this is our situation. So we had a retard stand. Okay, we had a stirrup. We had our rod, and we had another rod. Okay, and this moved away, let's say. Okay, so let's say this is polythene, and if it was moving away, charged negatively. Sorry. Okay, and this is also polythene charge, so both of those polythene charge negatively, and everything else follows through from there. Okay, so that's it. That's the notes from lesson 1.